All right, I am going to go through the answers on the practice test so you guys can use this as a guide to help study for your test, which is either on Thursday or Friday this week, depending on if you're maroon or gold. It will be in person, so whenever you are in person is when you are taking the test. But instead of doing the review this time, I wanted to make sure you guys had something that looked very similar to the test so you can make sure you get enough practice since we're not in person today for class. So feel free to skip around on this and go to the problem that you need to see the work on. But make sure, please, you are trying these first on your own as a practice. Then if you get stuck, come check the video to see the solutions. Your answers. If you still have questions in any of them, send me a message. Let me know you have questions on one and I can help you figure out where you're messing up or where you need help. Okay, so for the first one here, we are just solving. Remember, on all of these, we want to rationalize and simplify answers if they're in a radical. And when we solve radical equations, we're also going to solve or check for extraneous roots. That's when we have to plug it back in to make sure we don't get a negative inside. Okay, so first one, 5x squared plus 45 equals 0. We need to just solve for the x. So we want to start by getting that x squared by itself. So 5 from each side. So that will give us, maybe, come on, pen. There we go. Okay, so that will give us 5x squared equals negative 45. And then I'm going to divide each side by 5. So we get x squared equals negative 9. And by the way, I'm doing it this way rather than doing like factoring or quadratic formula because there's no x term. It's just the x squared and the constant. Then once I get x squared by itself, I can take the square root of each side. The square root of x squared, that is just x. And then because we introduced that radical, we need a plus or a minus. And then we did the square root of negative 9. So remember, when you have a negative in there, we're always going to take out an I. And then the square root of 9 is 3. So this will be plus or minus 3i. Be our two answers there, positive 3i and negative 3i. All right, number 2. This one, it's we're solving for x. Again, this time it's x cubed, or pay attention to your exponent. The x cubed is already by itself, so I don't have to do anything to get the x term by itself. I can just go ahead and do on both sides to get rid of the cubed. I'm going to do the cube root of each side. The cube root of x cubed is just x. And then if I want the cube root of negative 125, because it's a cube root, I don't have to worry about plus or minus. And because it's a cube root, so since that index is odd, I can actually take the cube root of a negative number. So this answer is just negative 5. You don't have to worry about imaginary numbers if you're doing an odd indexed radical, because a negative times a negative times a negative would make that negative 125. So x is just negative 5 there, right? So first one, we were doing a square root with the negative inside, so we have to worry about I. When we do a cube root of a negative number, then the answer is just negative. Okay, this next part, remembering what the discriminant is. Remember, the discriminant is the part that of the quadratic formula that is inside the radical. So your discriminant, remember, is the b squared minus 4ac, that part of the quadratic formula. If when I plug in my a, b, and c there, if I get a positive number, that means there's a positive inside the radical. So there are going to be 2 real roots because I'm taking the square root of a positive number. If there's a negative discriminant or a negative inside that radical, then there's going to be 2 imaginary roots because now I'm taking the square root of a negative number. And if the discriminant is 0, then that means when I take the square root of 0, that part goes away. There's no more plus or minus, so there is only 1 real root. Okay, and we'll do a little bit more with the discriminant on a later question. All right, this next one, directions here are very important because on this one it says, if you correctly solve this equation, then you will get the following answers. So notice that here it's actually giving us the answers. I don't have to actually solve this equation. It gave me what the answers are. Then it just says to show the check to determine if one or both of the solutions actually work. So basically we've got this equation, this radical equation, because we've got variables inside these radicals. It has already been solved, and there are the answers. I just need to check and see if either of those answers are extraneous, or if they both work, or maybe both of them are extraneous. So all I'm going to do is check each one. So for the first one, I'm going to check that x equals 3. So we just plug 3 in, right? So I've got radical 5 times 3 plus 1 equals 2 plus radical 3 times 3 minus 5. And then don't do any solving. Don't start squaring both sides. Just do order of operations. So I'm going to do everything inside the radical. That would be radical 15 plus 1, which is 16, equals 2 plus radical 3 times 3 is 9, minus 5 is 4. The square root of 16 is 4. And then I get 2 plus the square root of 4 is 2. So we get 4 equals 4. So that x equals 3 checks out. That is a good solution. Then the second one I need to check is x equals 7. So we'll do the same thing. Square root 7 times 3 plus 1 equals 2 plus radical 3 times 7 minus 5. 7 times 3 is 21 plus 1. That's radical 22. And then we've got 2 plus square root of 21 minus 5. That is, oops, I did that wrong, didn't I? I did the left side wrong. Sorry, guys. We actually want 5 times 7. There we go. So that's 35 plus 1, that's 36. And then on the right, 21 minus 5 is 16. Square root of 36 is 6. And then over here we get 2 plus the square root of 16 is 4. Oops, sorry. That shouldn't be in the radical. So 2 plus 4, I did the square root. So then again we get 6 equals 6. So that one also works. So that means that both of our solutions work. So x equals 3 and x equals 7 are both good solutions. They both work, right? It is possible to get where one of the solutions doesn't work and one of it does work. It's also possible to get a situation where neither solution works. And if neither works, then that means there is no solution. Okay, so just checking on that one. Don't actually have to solve. All right, the next two, we've got radical equations, maybe. So this one is definitely a radical equation. I've got an x inside of my radical. So remember, whenever they are radical equations, we've got to check for extraneous solutions after we finish. So on this one, to get rid of that cube root, I'm going to cube both sides of the equation. 3 to the third power, that's 3 times 3 times 3, that's 27, equals, when I cube the cube root, those two things cancel each other out, so we're just left with 4x minus 5. I'm going to add 5 to both sides, so I get 4x equals 32, and then divide by 4, I'll get x equals 8. Right? Because that's a radical equation, I'm going to check it really quick and do 3 equals the cube root of 4 times 8 minus 5. That would be 32 minus 5, which is the cube root of 27, and the cube root of 27 is 3. It checks, so x equals 8 is a working solution. Okay, okay, number 6. This is the one we've talked about before. Now you can solve this two different ways, but if you want the easier way on this one, you may notice that in the radical, that is not a variable, right? That is a number inside that radical. So this is not a radical equation. So that means we can solve it without actually squaring both sides. So instead, all I'm going to do is on this side, they both have an x. So I'm going to factor out that x. So if I take out the x, 2x divided by x is 2, plus x radical 3 divided by the x is just radical 3, and then equals 5. And then to get the x by itself, I'm going to divide the whole thing by 2 plus radical 3. And I got to do that on the other side as well. So then that goes away. We get x equals 5 over 2 plus radical 3. Except I can't leave my answer like that. I don't want to leave a radical in the bottom because it's a binomial, meaning something plus something. I can't just multiply by radical 3. I have to multiply by the conjugate to rationalize this. So remember, the conjugate is the exact same thing, the 2 and radical 3, but I'm going to change the sign in the middle. So I want to multiply by 2 minus radical 3 on both the top and the bottom. And then I'm going to multiply that all out. So on the top, I would get 10 minus 5 radical 3 when I multiply. On the bottom, remember these are conjugates, so those middle terms are going to cross out. But then I'll get 2 times 2 is 4. I'd get minus 2 radical 3 and then plus 2 radical 3, but those two terms are going to cancel out. So then positive radical 3 and negative radical 3, I will get negative radical 9, which is just 3. So then if we simplify that, we get x equals 10 minus 5 radical 3 all over 1, which we don't really need the over 1 on the bottom. So it's just 10 minus 5 radical 3 for our answer. Okay, now you can do the squaring thing on this one to get rid of the radical, but it makes a much bigger mess. It is way easier if you recognize that this is not a radical equation and you can just factor out that x. Much, much simpler that way. Okay, all right, next one, number 7. This one is a radical equation. We do have a variable inside our radical, so we're going to solve it by squaring both sides, and then we need to check our answer for extraneous solutions. So we'll start here by squaring both sides. Remember, you can't just square each term here. I've got to write that out twice and multiply, right? So on the left, when I square that radical, they cancel each other out. We're just left with x minus 1. But on the right side, I've got to do x minus 3 times x minus 3 and do my distributing. So then we'll get x minus 1. This will be x squared minus 3x would give us a minus 6x. And then negative 3 times negative 3 is positive 9. Then, because I see the x squared in the x term, I know I've got a quadratic, so I'm going to have to solve either by factoring, quadratic formula, complete the square. But first I want to get this all equal to 0. So I'm going to subtract over the x, and I'm going to add the 1. So then I will get 0 equals x squared minus 7x plus 10. I'm going to check to see if I can factor first, because I think that's the easier way to do these. Can I come up with two numbers that will multiply to make 10 and add to make 7 or negative 7? The answer is yes. I can use 5 and 2. So then I get my two factors. I can do this the shortcut way because it's just a 1 in front of that x squared. So x and x, 5 and 2 multiply to make 10. If I make them both negative, they multiply to make a positive, and they add to make the negative 7. Then once I've got my two factors, I'm going to set each factor equal to 0 separately. Add 2, I'll get x equals 2. And then over here, I get x equals 5. Then once I get my two answers, I've got to check both of these. So I'll start with the 2. So first I'm going to check, oops, if I spelled check right. Come on, pen. Okay, well, there we go. Come on. Okay, so first I'll check the x equals 2. So the square root of 2 minus 1 equals 2 minus 3. I can tell that one's not going to work because the 2 minus 3 is going to be a negative. So this would be the square root of 1 equals negative 1. That gives us 1 equals negative 1. So that one actually does not work. X equals 2 is an extraneous solution. So you don't have to write this on the test, but I'm just going to write it on here so we know that one doesn't actually work. And then I'm going to check my x equals 5. Make sure that one works. So for that one, I get radical 5 minus 1 equals 5 minus 3. That's the square root of 4 equals 2, and that means 2 equals 2. That one does check out. So that means my only answer for this problem is x equals 5. Okay, this is one of those examples where you have to do the check. We've done this before where we had fraction equations and people forgot to check, and you'll lose an entire point if you don't do that check and you think they're both the right answer. So don't forget, on the radical equations, you've got to check for those extraneous solutions. All right, a couple on our next page. Now we're looking at completing the square and quadratic formula. Hopefully we've got these down now. This is the second time we've been through this process. Okay, so completing the square, remember step 1, we want this first term to be a 1. So I'm going to divide the whole thing by 2 to make that be a 1. So then we get x squared. Oops. We have plus 2x plus 5 equals 0. I can look at that. It doesn't factor. Nothing multiplies to 5 and also adds up to 2. So we could use completing the square like it told us to. I'm going to use that method that it says. So remember, first step is move c over, and we're going to make our new c. So x squared plus 2x. We're going to add in our new c value. Move the 5 over to the other side, so it'd be negative 5. And then again, plus our c value. To get c, remember, we take half of b and then square it. b is 2. Half of 2 is 1, and 1 squared is 1. So we're going to do x squared plus 2x plus 1 equals negative 5 plus 1. Then, remember, our left side is now a perfect square trinomial, so it will always factor to x and then plus half of b. Now you pick the plus because the plus is there. Half of 2 is 1. So this would be x plus 1 squared equals negative 5 plus 1 is negative 4. Now that I've got it to look like that, I can take the square root of each side to get rid of that squared. And then I just get x plus 1 equals, this is kind of the little difference from the last time. We still need our plus or minus, but there's a negative inside that radical. So the square root of negative 4 is not just 2, it's 2i. And then our last step is to subtract the 1 on each side. So we get x equals negative 1 plus or minus 2i. And we can leave our answer like that. There's nothing to simplify. Okay, number 9, we want to solve this time using quadratic formula. For this one, I don't have to get a equal to 1. It can be whatever, but I do want to make sure I put this in standard form, so I want it to be equal to 0. So I'm going to rearrange this a little bit by moving the 6x over to the left side, and then I'm going to put them in order. So 2x squared first, then our minus 6x, and then plus 7 equals 0. And then remember, that's our a, this is our b, and our c. So now we're going to plug it into our lovely quadratic formula. Hopefully you've got this down by now. That one is x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. Okay, so then when we plug it in, we get x equals the opposite of b. Since b is negative 6, I'm going to put positive 6 plus or minus square root b squared, that's negative 6 squared. Don't forget your parentheses, that's important. Minus 4 times a times c all over 2 times a, which is 2. Okay, and then just one step at a time here. That means we get 6 plus or minus. This would be a positive 36 when I square negative 6. Negative 4 times 2 is negative 8, and then negative 8 times 7 would be negative 56. All over 2 times 2 is 4. So then we get 6 plus or minus. 36 minus 56 is negative 20, all over 4. That's where we get our I, right? So now we have a negative inside that radical. We don't just say no real solution anymore. We can fix this by taking out an I, and then we can simplify our radical 20. We'll do that here in the next step, all over 4. So then radical 20, if I do the factor tree, I get a 4 and a 5, and then the 4 is a 2 and a 2, so we get a pair of 2's. So we get 2i radical 5 all over 4. And then our last step, the 6, the 2, and the 4 are all divisible by 2. So we're going to get 3 plus or minus. That 2's gone. It's just I radical 5 all over 2. There's our solution for that one. Okay, so quadratic formula like normal, just when you get a negative, or if you get a negative inside the radical, make sure you take out the I. Okay, a couple other new things we've learned here. Back to that word discriminant. Remember, the discriminant is the part of the quadratic formula, like we just did back here, that's inside the radical. So we're looking at that b squared minus 4ac that's inside the radical. Is all we have to do. You don't have to solve the entire thing, right? So to get the value of the discriminant, here's my a, b, and c. So b squared would be 4 squared minus 4 times a is 6 times c is 1. 4 squared is 16, and then negative 4 times 6 is negative 24. Negative 24 times 1 is negative 24. And then 16 minus 24 would be negative 8. So the value of the discriminant is negative 8. Right? Because we have a negative underneath our radical, that means we're going to have our 2 imaginary roots. So this would have 2 roots, and our roots will be imaginary because it was a negative under that radical. Okay, if it was a positive, we'd have 2 real roots, and if it's a 0 for the discriminant, then we have 1 real root. All right, writing equations. This is what we did on Friday, so just in our last class. So this one will be one to kind of make sure you get some review on. If I want to write a quadratic equation with integral coefficients, that means I want whole numbers, no decimals or fractions, where the roots are negative 7/2 and 4. Right? So this is where no matter what your roots are, you can always start by making your factors x minus 7/2 and x minus 4. So whatever, it would be minus negative 7/2. So this would actually be plus 7/2, right? So whatever your roots are, it's just always x minus whatever that root is. We can set that equal to 0 and then multiply it out. So here I do x times x, I get x squared. X times negative 4 is negative 4x. 7/2 times x would be plus positive 7/2 x. And then 7/2 times negative 4 would be negative 28 halves. But 28 divided by 2 would give us 14. So that's negative 14. Here, I don't want to have to mess with those fractions there, so we can always multiply through by 2 to get rid of the fraction. So that would give us 2x squared minus 8x plus 7x minus 28. And then combine our like terms, we get 2x squared minus x minus 28 equals 0. And there's our quadratic equation with integer coefficients. Also remember, you could have also set this up, we'd still have our x minus 4, but if it makes sense to you to kind of work backwards here, this would be 2x plus 7. If you want to think of it that way, you could have set that up, multiply that all out, you'll get the same exact answer. Okay, so either way works there. Do the same thing with our imaginary roots. Remember, if you've got plus or minus, that means one of them is plus and one is minus. So again, we're going to set up our two roots. I'm going to do x minus, and then we've got 5 plus 4i. And then our other root would be x minus, and it's 5 minus 4i. And then we multiply that all out. First, I'm going to distribute those negatives. So I'll get x minus 5 minus 4i, and then x minus 5 plus 4i when I do the negative times a negative. Now we're going to distribute everything. X times x is x squared. X times negative 5 is negative 5x. And x times 4i is positive 4ix. Next, I distribute the negative 5, so I get negative 5x. And then I'll get plus 25, and then a negative 20i. Finally, distribute the negative 4, so I get negative 4ix plus 20i and minus 16i squared. And find your like terms and combine those. We've got a positive 4ix and a negative 4ix. Those are gone. I've got a negative 20i and a positive 20i. So those are gone. Then the rest, we've got just 1x squared. I've got a negative 5x and a negative 5x, which makes minus 10x. Then I have a plus 25. And then remember over here, our I squared is actually a negative 1. So negative 16 times negative 1 would make a positive 16. So we get x squared minus 10x. 25 plus 16 is going to give us 41. And then all of that, I forgot my equal 0 up here, but all of this equals 0, right? So there's our equation with those two imaginary roots. Now, again, that's the easiest way if you want to do the same thing every single time. If you like to see the other way to do this one, you kind of think about this as x equals 5 plus or minus 4i. And I'm going to unsolve that. So I get x minus 5 equals plus or minus 4i. And then I'm going to basically square both sides to, I'm going to get back to the radical on the right side. So I have to think about what did I have to take the square root of on the right side. And it's basically like squaring that. So this would be like the square root of, square root of, no, just kidding. We're going to square both sides, sorry. So I'm getting 16i squared. And then this was x minus 5 squared. 16i squared, well, if I go back to putting that in the radical, that is just the square root of, negative 16 is how I would have gotten to that plus or minus 4i, because I squared is negative 1. Then I'm going to multiply out the left side, so we get, x squared minus 10x plus 25 equals that negative 16. Add the 16 over, and again we get our plus 41 equal to 0. So we get that same answer, right? If this way, this blue way, does not make sense, stick to over here, the green way, where you always just subtract. But I want to make sure I show you both of those options. All right, then our last one is the word problem. A family photo is 2 feet wide by 3 feet long. So I'm going to start by drawing that picture, right? So we've got 2 feet wide, 2 feet wide, 3 feet long. We've got our picture, right? So we'll put 2 by 3. The photo is going to be put in a frame of uniform width. Remember, uniform means it's the same width all the way around. So we're going to have a frame going around our photo. So I'm going to draw that in. The frame, the area of the frame is going to be 8 square feet. We want to know what's the width of the frame need to be. So basically we're going to use that the area of the frame is 8 square feet, right? But to get that area, I don't know the dimensions of these sides. So that's where we talked about, well, I know the width of this frame is what we're trying to find out. So we're going to call that X on all 4 sides. So then that means the dimensions of this would be 2 plus 2x, because I'm taking, let me write it this way. If I look at this whole length, this part is x, this part is x, and this part is 2. So if I add those all together, then that means that this is 2x plus 2. On this side, we've got x here, we've got x here, and then this whole piece is 3. So on this side, we've got 2x plus 3 as our dimension. Okay, so then for our area, we know we want the area of the frame to be 8 feet, or 8 square feet, sorry, so that should equal 8. To get the area of just the frame, that border that goes around the picture, we want to take the area of the whole thing, so the total area, and we're going to subtract the area of the picture, right? So if I take the area of this entire rectangle over here and subtract out the picture in the middle, that would leave me with the area of just the frame. So that would equal 8. Okay, well, our total area would be those two dimensions multiplied times each other. So 2x plus 3 times 2x plus 2. And then I'm going to subtract the area of the picture. Well, that's easy because we know it's 2 by 3. 2 times 3 is 6, and that will equal 8. I'm going to multiply out all of my 2x plus 3 times 2x plus 2. So we get 4x squared plus 4x plus 6x plus 6 minus 6 equals 8. We get 4x squared plus 10x. The 6 and the minus 6 cancel out, so we just have equals 8. That's a quadratic, so I'm going to get it equal to 0. So 4x squared plus 10x minus 8 would equal 0. To make this easier, I can divide all of that by 2. So we get 2x squared plus 5x minus 4. If I try to factor that, I would need something to multiply to negative 8 and add to 5. That is not going to work because all I can do to multiply to 8 is 2 and 4 or 1 and 7. That's not going to give me a 5. So I'm going to use either complete the square or quadratic formula to solve. I'm going to go ahead and do quadratic formula. So there's my ABC. So x equals the opposite of b, so negative 5 plus or minus square root b squared, so 5 squared minus 4 times a times negative 4 is c, all over 2 times a is 2. That will give us negative 5 plus or minus, that's 25. That would give me negative 4 times 2 is negative 8. Negative 8 times negative 4 would be positive 32 all over 4. So now we've got x equals negative 5 plus or minus 25 plus 32. That's the square root of 57 all over 4. So that would be our exact answers. But like I said, on a quadratic story problem like this, it makes more sense to give an approximate answer. And also, if we get a negative answer, then that doesn't make sense. So then remember, you've got two possibilities, -5 plus radical 57 all over 4, or -5 minus radical 57 all over 4. Now, I can look at the second one and know that this answer is going to be negative. So I know that this is not the one that I want, because I'm going to have a negative minus another number, which is just going to make it more negative, and then divide by a positive, right? So this is the one we want to get our positive result. I'm going to do the square root of 57. So we get -5 plus, that's about 7.55, and then divide that by 4. Put that in my calculator. Divide by 4. I get 0.64 approximately if I round that. So that means the width of the frame is, we did this in inches, right? Go back and check. Oh, no, it's feet, right? So it'd be 0.64 feet. You don't have to change that to inches or anything. That's fine just to leave it in feet. Okay, so draw your picture, set up your equation. Make sure you write your answer in a sentence when it is a word problem. I'm not going to take off for a let statement on this, but if you need to do a let statement at the beginning, that might be a good idea as well. But hopefully that helps with the answers to that practice test. Again, make sure, hopefully you tried them on your own before you just came and watched all the solutions. But I will see you guys Thursday and Friday for your test. Hopefully we're back in school on Wednesday, and you can stop by on a PRT if you should need help then, or contact me today during class time and we can go over questions if we need to. That's all.